So let us begin. All right, so pretty sure all of us here, there's no new member. You know my name, so it's just a matter of us going into a serious way without me introducing myself. So today we're looking at quadratic functions. And what we're going to start with before we go into quadratic functions, there's a small topic that we left last time, which is just solving absolute value equations. So that is what we are basically going to start with. So every time we hear about absolute value equations, this is what you should have in your mind. This is what should come in your mind. And then whenever you see these two symbols, as I explained in the previous lecture slide, these two lines here outside x, note to say we're talking about the modulus or the absolute value. It's just the same. And then when solving such equations, let's say for instance you have the absolute value of -2. When you have the absolute value of -2, this is always +2. Yeah. So in other words, whether this x is negative or positive, it will always give you 2. So what am I trying to say? When you're finding the solutions of the absolute values, this is, first of all, you have to equate, meaning this x can either be a positive or a negative x. Okay, so when this x is positive or negative, whether it is positive or it's negative, it will still give you what? It will still give you a positive a. I don't know if you've gotten my point there. Whether this x is negative or positive, you still get a positive number. This is what it means when you talk about modulus values. Okay, so let us try to look at certain questions, and then I'm pretty sure to say after looking at these questions, we're all going to be fine with solving these. They are simple. Yeah, I know that everyone is going to understand them because they are simple and straightforward. So we'll look at A. A is saying the negative of 2x minus x in absolute value symbols is equal to 6. So how do you solve such an equation? How do you find the solution for this equation? Because our question here is saying solve each of the following. So when you've been asked to solve something, it means that you have to find the solution. Yeah, meaning this is a problem, you have to find the solution. So let us now solve. I'll start with A. So A is saying -2x minus 1 is equal to 6. So what we're going to do, we're going to get this. This is what we're going to do. So meaning we'll first equate this -2x minus 1 to +6, and then we'll come and equate this same -2x minus 1 to -6. So we start with equating it to +6. So this is what we're going to have. Okay. Then you also have to equate it to -6. So this is what we're going to have. All right. So now here is just a matter of solving the two equations. The first one here, when you take this -1 to the other side of the equal sign, you're going to have something like this. So this -1 will be a +1. Yeah, in other words, mathematically, we call it the additive inverse. Yeah, so when you take the additive inverse on both sides, this side and this other side of the equal sign, you're going to have this -1 changing to a +1 this side, which is just going to be 6 plus 1, which will give you what? A 7. Yeah, to give you a 7. So I mean, when you finish solving this, you have something like x is equal to, when you divide both sides by -2, you're going to have -7/2. Yeah, so this is your first solution. Try to replace it there. You see if it's going to give you positive 6 as your answer. And then we also have to solve this one. So this one will give us this negative 2x. And then when you find the additive, we have minus 1 here. So when you find the additive inverse of this minus 1 is a positive 1 this side. So whatever you do this side, you also do it on the other side. So we have added a 1 this side. You also add that other one to the other side of the equal sign. So this will give you a 0. Then that side, this side will remain with 2x. Then this other side, you are going to have negative 6 plus 1 to give you negative, yeah, to give you negative 5. So here you have x being equal to, when you divide by negative 2 both sides, on both sides, you're going to have x being equal to 5 over 2. Yeah, so you can try to put 5 over 2 there, see if it's going to give you positive 6. All right. So this is yeah, this is what you basically need to know on such a question as this one. And then we move on to B. I'm sure everyone has understood A. We move on to B. So B here has two methods of solving it. So if you want, you can just do this. You introduce these brackets, you square this side, you also do that, you square that side, and then solve the equation. So when you square this side, you solve it, you are going to have something like 4x. You're going to have 4x squared plus 4x when you square this side, and then you have plus 1 being equal to, this side you get 16x squared. When you square this part, you're going to have 16x squared, then you have minus 24x, then you have plus 9. So when you solve this equation, you pair the like terms and then you solve the quadratic equation. The answers that you are going to get are the actual values of x. And then the other way you can solve this one, which is the simplest way if you don't know how to work out the quadratic equations, is by just getting this. You say 2x, you solve it the same way we solved the first one here. 2x plus 1 is equal to 4x minus 3, 4x minus 3. Then you do this, you demarcate, and then this other side, you say 2x plus 1 is equal to, you introduce a negative, and then you write that in brackets, minus 3, like that. So we start with this part first. When you take this 4x to this side, you're going to have negative 2x, because 2x minus 4x, you come and have a negative 2x this side. Then this side, when you take this positive 1 to this negative 3 this side, you're going to have negative 4 as your answer. Sorry, I wanted to write x. So you're going to have negative 4 this side. So when you divide both sides by negative 2, even this side by negative 2, you are going to have your x being equal to 2. So this is our first value of x. This side, we first start by opening the brackets. Of course, this is mathematics, you need to follow body mass. So you open the brackets this side, and then you multiply, and then you, I mean, by open the brackets, I mean you multiply this negative throughout throughout what is in the brackets there. So you have negative times 4x, you are going to have negative 4x, and then you have negative times negative 3, you are going to have positive 3. Then you take this negative 4 to this other side of the equal sign, you're going to have 2x plus 4x, which gives you 6x, and then being equal to, this is positive 1. Then when you take it to this other side of the equal sign, you're going to have 3 and then negative 1. So meaning 3 minus 1, which gives you 2. So here when you divide this side by 6, you also divide this other side by 6. You're going to have your x being equal to 1 over 3. So these are the two values of x. You can try to put them there, test them, see if you're going to get the same answer. So the one that gives you the correct answer, or the one that proves the equation is your answer. Try to put 2 there. You're going to have 4 plus 1, which is 5. Try to put 2 there. You're going to have 8 minus 3, which is 5. So these 2 qualifies. And then try to put 1 over 3 there. So when you put 1 over 3 there, you're going to have 2 over 3 plus 1. So 2 over 3 plus 1 gives you something like, is it 5 over 3? Yeah. And then you try also this one. You put 1 over 3 where there is x here. So you're going to have 4 over 3 minus 3, which gives you 4 minus 9, which gives you 5 over 3. Yeah, which is, I think it's also working. You try to do it on your separate paper there. See if it's going to give you the same answer. So I think it's also working. Yeah, let's move on to C. So C is saying the absolute value of x minus 5 gives you negative 3. So this one, just by looking at it, you can just conclude to say there is no solution for this question. Why do I say so? Look at this negative 3 and remember what I said here. I said when you find the absolute value of any number, whether positive or negative, the answer has to give you a positive answer. But in this case, you can see here, after finding the absolute value of x minus 5, we're getting a negative answer, which does not exist. Hence, this equation has no solution. So you just write no solution. If you meet an equation which is like that, just know to say it has no solution. All right. So you can finish it up. Then D there, D is saying 2, and then 2 is multiplying itself by x plus 1 in modulus value symbols minus 3 is equal to 9. So for such questions as D, you first need to simplify it. So you first need to simplify D before you work it out. So what do I mean by simplifying? So these 3 first to cross the equal sign, then we're just going to remain with 2, and then in absolute value we're going to have this x plus 1, like that. This is equal to 9. When these 3 crosses the equal sign, rather you find the additive inverse of 3's. You add it on both sides of the equation. You have 9 plus 3 there, which gives you 12. So when you divide by 2 this side, divide by 2 this side, you get your answer being equal to 6 this side. So this one even becomes easier now. You just say x plus 1 being equal to positive 6, and then you divide there. So you say x plus 1 again being equal to negative 6. Yeah. So from here now it's even simple. You take this positive 1 to the other side of the equal sign. You have your x being equal to 5, and then you take that 1 to the other side of the equal sign. You have your x being equal to negative 7. Yeah, so you can try it out. Put negative 7 there, you get negative 6. The absolute value of negative 6 gives you 6. Put 5 there. 5 plus 1, you get 6. The absolute value of 6, you get 6. Yeah. So these questions are just as simple as this. I don't know why people face a lot of challenges when it comes to answering these equations. So let's proceed now. We start quadratic equation, which is today's topic. So quadratic functions, rather quadratic equations, these are just this is my own definition. These are just uh, functions which have the highest degree of 2. So this is what I'm basically talking about. Any function which has the highest degree, which has its highest degree, uh, which is 2, is called a quadratic equation. Above 2 is called a polynomial. Less than 2, maybe for instance 1, is called a linear equation. Okay, so we have about 3, if not more than 3, methods of solving quadratic equations. And then the first one that we're going to discuss here is the factorization method. So factorization method is quite simple, yeah, because we learned it at high school and even at university level it's there. Actually, you just have to know it because it is used almost in everything that we do. So this is the simplest method if possible. For example, when you have x squared minus 4x minus 5 being equal to 0, this one gives x minus 5 uh, in brackets and then x plus 1, which is equal to 0. And then when you simplify this further, you get x is equal to 5 and x is equal to negative 1. However, there are certain quadratic equations that cannot be factorized, like this one here. So there are some quadratic equations that no matter how you can try to find its factors, is impossible. You cannot factorize it. So if you cannot factorize the quadratic equation, meaning you can use the other two methods, yeah, which is completing the square method or just the formula method. Okay, so I know somebody is asking themselves to say, how did this come to that? Simple. So what you do here is you have this equation there. So I make sure that I teach this even the simplest things so that you understand what we're doing. So if this session ends before I finish the slide, meaning we're going to also have the second session. Okay. So you first find the factors. So here the factors, or before we find the factors, we first find the product and the sum. This is grade 12 work. So product is 1 times, you multiply this, the coefficient of x squared and the constant. 1 times negative 5, you get negative 5. And then you find the sum. The sum there is just this part here, meaning it's negative 4. So meaning the factors there, you find two numbers that when you multiply them, you get negative 5. When you add them, you get negative 4. Which are these two numbers? So you can agree with me that these numbers, when added, you get negative 4. Then when you multiplied, you get negative 5. These are 1 and negative 5. When you add these two numbers, you get negative 4. When you multiply them, you get negative 5. So these are the numbers that you replace there. So you're going to have something like this. X squared minus x squared minus uh, minus 5x. If you want, you can start with 5x, and then if you want, you can start with positive x there, positive 1. You still get the same thing at the end of the day. So this is what we have, is equal to 0. So now we factorize. X is common there, so we're going to have x minus 5 in brackets. Yeah, there what we have which is common is 1. Then we have x minus 5 in brackets like that. There's supposed to be a minus there, is equal to 0. So here you get what is in the brackets there, which is the factor, because the factor is just, you get the common factor there, sorry. So, and then you get the remaining ones there, x plus 1, like that. is equal to 0. So here what you do again is you equate these. I mean, this part is just actually this one here. So you equate these to 0. So when you equate x minus 5 to 0, x minus 5 to 0, you're going to have this. So your value of x will just be equal to 5. Same applies when you equate x plus 1 to 0. Your value of x will just be equal to negative 1. Hope you're seeing what I'm writing. Yeah, these things are simple. All right, so we proceed. That is how we got x being equal to 5 and x being equal to negative 5. Yeah, so it is also important to note that the equation x minus alpha and multiplied by x minus beta is equal to 0. Alpha and beta are called roots of the quadratic equation. So meaning these answers that you find after factorizing a quadratic equation, they are called the roots of a quadratic equation. Yeah. Okay. So the second method is by completing the square. So remember what I said? I said if you cannot factorize any given equation or any given quadratic equation, it means that completing the square method can do, or the formula method can do. So see, this is what I'm even talking about here in the notes. Says since x squared minus 4x minus 4 is equal to 0 cannot be factorized, hence completing the square method can be used to find its roots. Yeah. So it's just as simple as that. So to solve it, you can change x squared minus 4x into a square. What do I mean by this? How do you change this into a square? This part here, how do you change it into a square? Um, Follow me properly here. So how do you change this into a square? This is where a lot of people get confused. So you write x squared the way it is, and then you say minus. Find half of this. What is half of 4? Or what is half of negative 4 rather? So you say plus. What is half of 4? Sorry, half of negative 4. So the half of negative 4 is simply negative 2. And then this negative 2, you square it. And then this same thing, this same part here, is the one that you repeat. You subtract it. So you're going to subtract negative 2 squared. So when you subtract this minus this, it's just the same as 0. And then you repeat this minus 4x. Minus 4x. Yes. So after doing that, yeah, if you got this whole equation, it means that you are also going to write this minus 4 this side. If you got the whole equation, then you say is equal to 0. So what you do here, you can now combine this. So you can say x minus 2. You put this as a square. This here the first point it's telling us to convert it into a square. So you square this, and then you write this minus here. You write it here, and then you say negative 2 squared gives you what? 4. And then this one, you just automatically cancel it. I know if you want to prove this, you can try to simplify everything. This here, you are going to see where this negative 4x is cancelling, and you are going to get back to this. So you cancel that and say minus 4 again. So this is equal to 0. So what do you do there now? Say x minus 2 k squared minus 8 is equal to 0. So you take this negative 8 to the other side of the equal sign. So when you take negative 8 to the other side of the equal sign, this is what you're going to have is equal to 8. Oh, sorry, this one is supposed to be squared. So from here, what you do, you square root both sides, this side and that side. Of course, this always moves with a plus or minus. I'm sure from there you can all finish it up. It's You can all finish it up. It's simple from there. Yeah. So this is what I'm trying to talk about. Yeah, I've gone through all these steps. So you can finish it up from there. Then the last one is just by the formula method. So the formula method, you first take this into consideration. Ax squared, this is the standard of a quadratic equation, ax squared plus bx plus c being equal to 0. So this is the formula. So when you look at this formula, this one is derived using completing the square method. When you complete the square of this, it's just that I don't have time here, I would have derived it. Yeah, but yeah, I'll see. If I'm going to have time at the end of the lesson, I'm going to derive this. It's simple as well. So when you complete the square of this, you are going to find yourself to this. Yeah. So what is here, this part here inside the square root, inside the root here, is called the discriminant, and it is denoted by D. It's the discriminant, and it's very important here. As I'm explaining, you might not see its importance, but when we begin to look at the types of roots, you are going to know why I'm saying it's very important. So yeah, this is what I'm just from saying, where D is equal to B squared minus 4AC, which is equal to the discriminant. So anyway, let us now talk about the graphs of quadratic functions. The graphs of quadratic functions. So graphs of quadratic functions are straightforward. We're going to discuss them in details probably on Monday. But for now, let me just show you what we mean. And every time you see this equation, this standard of a quadratic equation, when you plot the graph of this equation, it will either have a minimum or a maximum value. What do I mean? It will either face up or down. And this is always called and the product is always called the parabola. I mean, the curve is always called the parabola. Yeah, this is what we're talking about. So when the value of a, meaning this part here, when a here is greater than 0, meaning it's positive, then it's going to have a minimum value. And then when it's negative, it's less than 0, it's going to have a maximum value. When you have negative a here at the beginning, you are going to have a maximum value, meaning your curve is going to come out like this. When you have a positive number here, your curve will be minimum. It's going to come out like that. Hope you're getting what I'm saying here. Okay. So now let us discuss the types of roots. So on the types of roots, remember what I said, when you solve a quadratic equation, the answers that you get are always called the roots of that equation. So when you solve this quadratic equation here, the value of x that you're going to have is this, where D is called the discriminant. This is what I just talked about earlier on. Yeah. And then the first type of root that we're going to discuss is the real roots. Yeah. What are these real roots? So when you discover to say the discriminant is greater than 0, you have a positive discriminant. So when you replace your given values here, if this is your equation and the values that you've been given, you replace them here. When you replace them here, and then you discover that the answer that you get is positive, it's greater than 0, just know to say the given equation has two different real roots, meaning it has two different real numbers. After solving that equation, you have to get two different real numbers as your answers. Yeah, and the other meaning of that is it cuts the x-axis at two different points. So this is what we're trying to say. So you either get this part here as your equation, or this other part here. You can see that all these two curves are cutting the x-axis at 2 points. So this first curve is cutting the x-axis at that point and at that point. So meaning our discriminant is equal to 0. And it has a minimum value because when a is greater than 0, and it has a maximum value when a is less than 0. All right. Then how do you know if it has no real roots? So you can only know to say this given curve has no real roots when the discriminant is less than 0. So when the discriminant is less than 0, it means that it has no real roots. And what we mean to say it has no real roots, meaning it has imaginary roots. Imaginary roots, in other words, we're trying to say it does not cut the x-axis at any point. So it will look like this. So it will either be this one here, or if not that one, it's going to be like this one here. It will not cut the x-axis at any point. Okay? All right. So we proceed. And then we also have another set of roots which are called the equal roots. What are these equal roots? So when you talk about equal roots, we're simply talking about repeated roots. Have you ever encountered, or rather, have you ever found a question, maybe a quadratic question, after solving it, you find two same answers? Instead of finding two different answers, the values of x, you find two same values of x. So if you find that, just know to say the equation that you are dealing with has two equal roots or coincident roots or two repeated roots. And the implication of that is that the curve, when you sketch, or rather when you draw a curve of such an equation, you are going to discover to say that curve is going to have its minimum or maximum value at exactly the point along at exactly any point along the x-axis. This is what we're trying to talk about, meaning the discriminant is equal to 0. So when the discriminant is equal to 0, sorry, there's a mistake here. This is not supposed to be there. When the discriminant is equal to 0, this is not going to be there. So meaning you're just going to have your x value being equal to negative b over 2a. Yeah. And then, okay. Yeah, the discriminant is going to be equal to 0. This is what it means. So the curves will look like this. So meaning they are going to have their minimum or their maximum value at exactly any point along the x-axis, depending on whether it's minimum or maximum. Yeah, so these are the most important points that you need to know about the types of roots. I'm going to distribute this slide. You're going to go through it on your own, and I'm pretty sure that it's self-explanatory. Even when you just read the notes that I've prepared, you'll be able to understand what I'm talking about. So we have this example here. It's saying, what type of roots does 5x squared minus 3x plus 1 is equal to 0 has, or I mean have? Okay, so if you want to know the type of roots that this equation has, you need to test it by using the discriminant. So our discriminant is given by b squared. Just hope that time will not finish before we finish the examples. B squared minus 4ac. This is the discriminant. So you test your discriminant there. So our A is here, our B is there, our C is there. And then, so where there's B squared, we're going to put negative 3 squared. So minus 4. Where there's A, we put 5 there. Then where there's C, we put 1. Okay, so the discriminant there is nothing but equal to so negative 3 squared gives 9, minus 4 times 5 times 1, you're just going to get 20. So when you subtract the 2, you're going to get negative 11. 9 minus 20 gives negative 11. So this negative 11 is less than 0. So meaning D is going to be, our D there is less than 0. Sorry. So our D there is less than 0. And then what does it mean when D is less than 0? Meaning it has no real roots. So meaning you just conclude to say no real roots, or rather you just write imaginary roots. So it has no real roots. So it is just as simple as this. And now let us look at the second question. So this one has no real roots. So if this D was greater than 0, I would have said it has real roots. If it was equal to 0, then would have concluded to say it has equal or coincident or repeated real roots. Okay, so the next question is saying, for what values of P does the equation x squared plus px plus 9 equal to 0 have two real roots? So they have told us to say the discriminant is greater than 0. Why do I say the discriminant is greater than 0? It's because of this point. I've been told to say it has two real roots. Okay, so we proceed now. So in other words, they are trying to say b squared is greater than 4ac from b squared minus 4ac is greater than 0. So I've just taken b squared to the other side of the equal sign. So b squared from this, what is my b? My b there is simply p, which is p squared greater than 4. My a there is 1, and then my c is 9. So this is what you're going to have. You're going to have p squared being greater than 36. So when you simplify this, you're going to have p being greater than plus or minus 6 when you take the square root on both sides. So meaning p is greater, p is greater than plus or minus 6. This is your answer. Yeah, so at these two values of p, the given equation has two real roots. There's an exercise at the end. You are supposed to do it. Due to time, I think it's even ending now. This is the exercise, and then you need to submit it before Monday.